Minasan, konnichiwa, Zamurai Engineer desu. In this video, we'll take a look and start our discussion, orientation on the course, principles of steel design. So this course is another major subject of BS Civil Engineering. So let us talk about the course. So I'm your professor, Dr. EYPEI ZANTUA. I am a civil engineering graduate of Taguig City University and Japan Government Scholar in Engineering. So introduction to this course. After this video, you must be able to describe the course in your own words. You can recall its specification and references. You can even list the topics to be covered, and you can cite the details of grading system. So the course code is actually CE E6, PSD, short for Principles of Steel Design. PSD is a professional course common to all CE students and provides fundamental concepts, principles, and theories under structural analysis and design of steel elements in a structure. So we are given the word professional, which means this course is a very relevant course as a practical subject wherein the topics being discussed have what? Actual practical application for which in the future, in our career as an engineer, as a worker, in our job, we can earn money out of it. So this is what we mean by professional. So, and we are investing in this course, investing in terms of time, effort, energy. All our energy must be focused on the professional subject because these courses will give us the opportunity to earn money, okay? To earn a living. So this is common to all CE students, meaning common because there are about 6 different civil engineering specializations. So what are those? Number 1, structural engineering. Number 2, construction engineering. Number 3, transportation engineering. Number 4, environmental and energy engineering. Number 5, geotechnical engineering. And number 6, what is number 6? Water resources engineering. So those are the areas of civil engineering. And this course is, although professional, this is common to all of those specializations. Okay? What do you mean by principles? These are a collection of ideas, concepts, and theories which systematically work together to analyze and design a system of structure. Okay? System meaning there is a system, meaning it could be a single element, it could be a component, it could be an assembly of elements that would make up a structure. Okay, so this structure could be a building, this could be a bridge, and therefore, in reality, in practical application, this course has something to do in designing a system for which this system could be used as a relevant portion of a structure. Okay? And we will provide those concepts. We will introduce, discuss, lecture about it, explain it, and give examples, okay, so that you have a pattern. You can use those information as a guide in your future undertakings, whether you are looking to pass the board exam, whether you are looking to have a career in any of the civil engineering specialization. Okay. Let us take a look at the course specification of this PSD, or the Principle of Steel Design. So this course is 3 units, meaning 2 units lecture and 1 unit laboratory. So 2 units lecture means 2 hours, and 1 unit laboratory means 3 hours, a total of 5 hours per week. We have a prerequisite of this course to be what? Mechanics of deformable bodies. This is what we popularly call strength of materials. Okay. And another one is structural theory. So both of these are known prerequisite of this subject and must be studied. You must be prepared before taking this course. And every week, I am assuming and I am expecting you to review something and recall something, minimum knowledge from these prerequisites, in order for you to have the proper frame of mind to take new information, okay, which is about the steel design. Okay, so program outcomes of the civil engineering. A, apply math and science to solve complex CA problems. In this particular case, we will solve steel design problems. And you have to apply your knowledge in math and science as an enabling course. Okay? So math and science enables you, will enable you to apply those learned information, principles into this new course, which is a professional one. Okay. Letter B, design, analyze, and interpret data. We will discuss to you how to design, how to analyze, and interpret those results in an introductory way, because this subject is 6 hours in the previous old curriculum, and currently it's only 5 hours. So therefore, it would be what? Compressed, somewhat compressed, and we are only allowed, because of the coverage, to tackle those introductory topics. Okay? We cannot do so much within this limited period of time. Okay, so letter K, use techniques, skills, and tools necessary for civil engineering practice. If you are a student of civil engineering who is also taking up principles of reinforced and pre-stressed concrete design, you will notice that this is similar. Why? Because this is also a professional course, same as PRPC. PSD, same outcomes that we expect. So this is our expectation. This is your expectation. What do you have to do? These 3 are your outcomes. Okay, similar to design courses, professional design courses. Okay, and what about this course outcome. What is the objective of this? Throughout the whole semester, we will give you the lecture and opportunity to solve problems and by taking into account these 4 objectives, wherein we will make sure that at the end of the semester, we will be able to what? Understand the stress-strain characteristic in both elastic and plastic deformation. Well, there is somewhat similar to reinforced in pre-stress design. But now, this is more detailed because it is steel design and we are using steel as a material, and steel is the most studied material. Steel is the most studied material. And humankind already has a good precision and accurate model, description, result, scientific result of steel as a material, okay? Compared to other materials like wood, like concrete, okay? So steel is actually we can design a steel specific to a particular application, okay? For example, they are able to design a type of steel that has a characteristic that would be able to hold the load in the application, in a bridge application, long span bridge application, wherein international shipping cargoes moves back and forth underneath this bridge, and that bridge is actually a popular bridge in Japan, wherein using the standards, using the learnings, the current technology are not enough. Using the principle, the theories of the current technologies are not enough. Using the tools, equipments, okay? The theories, the principles, the design techniques, the design method, assumption, modeling was not enough to be able to successfully put up a structure that would be satisfactory applied in that application. That popular bridge application in Japan was designed by researching further. So meaning to say, they actually research if they can improve the characteristic of steel material, okay? And they are able to do so. They improve the characteristic of the material over and above the current level of research and technology, okay? They are able to make the material stronger, more ductile, more tough, okay? So those are the characteristics that they improve in order for the simple material as steel, common material as steel, to be used in a very specialized application, okay? Okay? So this means we have plenty of range of proportion, crystallization, characterization of steel in order to produce different results. And if we are talking of two major characterization, we have what? Elastic deformation part and plastic deformation part. So steel has a good characteristic in both of these parts. Okay, and it is, I think, the only material in the world to have a very good characteristic in this both. Using the fact that steel is the most studied material, they can still what? Add to the knowledge. They can still improve. That is the first time that they improve that material in order to use as a bridge material. Okay, so the material is suspension bridge, suspension type of bridge to cable. Steel cables must be used, and the steel cable must be able to hold a great amount of load. Okay, okay, not just the vertical load, but fluid load. The cable will be used beneath the what? The water. So there are strict application. Okay, so there are still plenty of things to be done. That's why I always view myself as being smaller than a dot. I am smaller than a dot because if I look at the solar system, at the galaxy, at the Milky Way galaxy, I am very small. I am smaller than a dot. Meaning, I would like to study more. I would like to study engineering, many other engineering disciplines. Okay? I have plenty to learn. There's so much room to learn. Okay? So, if you feel the same way, you can study many things. Your mind will open itself for learning. Okay? If you feel that way. So, it's very good perspective to have. Number two, you must be able to determine the strength of structural steel in axial, bending, shear, and torsion. Okay, number three, apply both the ASD and LRFT design methods. Okay, later on, you will know what do we mean by ASD and LRFT. And number four, determine the strength of bolted, riveted, and welded connection, because steel material can be bolted, joined together by means of rivets, and joined together by means of welding. Okay? And we have the following course outline according to the policies and standard guidelines for BA Civil Engineering. So number one, introduction to the steel design. Okay. So this video is an introduction to the course, but this number one is introduction to the topic steel design. Okay. Number two is specification, loads, and methods of design. Number three, analysis and design for axial tension. Then analysis and design for axial compression follows. Number five, analysis and design for flexural members. Take note, we are always using the word analysis in design. Okay? We have very specific meaning pertaining to analysis and design. They are different from each other. Okay? Number six, shear strength of structural members. Number seven, combined axial tension and flexure. There are several ways we can combine tension, compression, flexure, torsion, but the most common and the most used, most utilized, most applied combination is tension and flexion. So there are other combinations. Okay, but because this course is intended for you to learn about the design and analysis in introductory course, so this is the standard policy of the government to only give us the opportunity to learn up to this part. No? And after which, number 8 is about connection. What do we mean by connection? As we have discussed in the previous slide, we will take a look how to bolt metal elements, how to weld metal elements, and how to rivet metal elements. Not in terms of mechanical engineering, how to handle it, how to do it, but how in terms of what happened. Okay? What happened? What would be the result? What stresses? What strength? Okay? What specification? What standards are related to these things? So we'll take a look at that. And those list is actually the coverage of this course. Textbook specification for structural steel buildings by AISC. AISC meaning American Institute of Steel Construction. And at your center, at the middle, we have NSCP, National Structural Code of the Philippines. This is the latest edition, 2015. By ASEP or ASEP, meaning Association of Structural Engineers of the Philippines. Okay? And we have a textbook here on your right-hand side, titled Structural Steel Design by McCormack and Cernak. So this is one of plenty of authors available in the market. So I'm using this one. You can also use other authors. I may also use other authors. It doesn't matter. What matter is you need to have at least one textbook. We need to have at least one textbook. Right. The code is about AISC or American Institute of Steel Construction, which allows us, together with NSCP, allows us to have what? To have information, data, tabulated data, which is very, very important in actual. This is very important in actual and design and analysis. Okay? So without which, we will have an experiment and trial and error without these tables. Do you want us to have a trial and error in the design and analysis at this level of technology? So we have to refer to those experts who made these tables. Okay? They are the authorities. Okay? And in a single collected association, they are actually plenty of members, of committee members, authorities about this, expert about this. They are committee under the Association of American Institute of Steel Construction, AISC. Okay. Very important. It is possible to download this for free. Just look for the older version because they are free, and the newest version they are for sale. Okay? So just look for the older, and we will use the updated one in our own job, in our career, in our design, work, but we can use the older one in order to do with the design without paying for so much. Right? One book like this is about what? 15,000. About 15,000. This one. Okay. Plus the shipping fee from United States to the Philippines. Okay. So it is a lot. So if you have two design subjects and you want the latest, so you have to pay 30,000. So a school, an institution can do that, but a particular professor cannot do that. No. Okay. So we have handbooks and reviews that may also help us. So we have on your left side the blue book, Simplified Steel Design. We have on your right side the green book, which is Structural Steel Design. Okay. So they are from different authors. They are not actually really expressing the color of the book. They are code for the author's name. Okay. Handbook of Structural Engineering, second edition, is a handbook, but it's not a textbook. So reviewers and the handbooks could support our main textbook as a study material, but it's not the main reference. Okay, so they are helpful in our study, but you have to first study the textbook. Okay, then if you already study the subject, the course, you can now start to take a look at these reviewers. Okay, so they are very useful in such a way that they summarize so many chapters and only a handful of pages. Okay? Reviewers summarize those concepts and principles in several pages, handful of pages only, and concentrate on problem solving. While handbooks are doing the opposite. They are summarizing the whole content. In that case, the whole content of the coverage of the course will also be compressed, but they are focused on